Hello, this is episode 4 of Reversing Game Shaders. Last week I did some preliminary exploration of the vertex shader, and today I will experiment with the pixel shader. This pixel shader uses shader model 3, defines two constants C10 and C11, then it defines several inputs, some of which are 2-element and some of which are 3-element. And then it defines two 2D samplers, S0 and S1, and S0 corresponds to this texture, and S1 corresponds to this texture. So now I know where the inputs to the shader are, but where's the output? The output will be stored in OC0. This is where the final output color is written. Now how this final output color is calculated is fairly complicated and will be dealt with in another video. But today what I will do is just do some simple experiments to show you how the inputs of the shader look when rendered out. In the first experiment I will define a new constant C12 and I will set it all to 1s. Then I will delete pretty much the whole shader and write my own, in which I will copy constant 12 into the output color and then render it. As you can see, the whole pistol is white because I set the output color to be 111. So this is the red component, green, blue, and alpha. So if I want it to be all red, I'm going to make the other colors 0. There's red. There's green. And then there's blue. So in the previous experiment, I manually set the color of the gun to just be a constant. In this experiment, what I want to do is I want to start by outputting this input V0 into the output color. So I'm going to make constant 12, all zeros except for the W component. I'm going to move it into the output color to just zero everything out. And then I'm going to move the first two components of V0 into the output color. I'm going to render that. So what this rendering shows is the XY values for each pixel. And what do these colors represent? Well, if you look at the muzzle here, for example, and look at what the output color is in hexadecimal. So this will actually correspond to a UV. So let's kind of pick around this point, D5, 8E. Now I already did some math beforehand. So let's see, D693. So let's suppose we picked that color on the muzzle. The D6 in hexadecimal would convert to 214 in decimal. And then converting 214 to a floating point would yield 0.84. And then multiplying that by the size of the image, which is 1024, we get 860. And doing the same thing with the Y component, we would get 594. Well, going back to the textures, there's our texture. In DirectX, the image or the texture origin is the upper left corner, 0, 0 over here. You can see the XYs down here. So if we come out to, what was it? 860, 594. 860, 594. Okay, so it's around here. So you can see that in the texture, the muzzle end is right here, which matches up with the coordinates that we got from the V0 input rendered to the output colors. So now we know that V0 is definitely the UVs, the texture coordinates. Now I also found that V7, so I'm going to change V0 to V7 and render, looks exactly the same. So V0 and V7 both contain texture coordinates. In the previous episode, I determined that the vertex shader output text scored 5 were the vertex normals that have been transformed by some matrix. Now I'm going to render the result of that transformation in the pixel shader by setting the output colors to V5. One of the simplest pixel shaders is a shader that uses the diffuse map as the colors. And I implemented it in the following way. I used a texture load command with using the first sampler and then using the UVs in V0 and then loading that into R4 and then storing R4 in C0 and then setting the alpha to 1. So I'm going to hit apply to render it, and as you can see, the diffuse map has been used as the colors without any other information. Now if I want to then, let's say, use the normal map, I will switch to S1, and then we have our normal map. And now that I know that V0 and V7 contain UVs, I can change V0 to V7 and the output should still look the same. And that is the case. I've shown you a few of these inputs rendered out, and now I'm going to show you the rest of them one by one fairly quickly because I still have not figured out what they mean. So for example, V1 looks like this. V3, V2, and then V6. How these are used in the pixel shader is yet to be determined. Thanks for watching Reverse Engineering Game Shader series. In the next episode, I will begin going through the vertex shader in detail. Tune in next time and keep your powder dry.